Welcome to this demonstration of Pilot 5, energy efficient, health safe, and sustainable smart buildings from the AerOS project. In this video, we will dive into the deployment of the IoT service of the Pilot that has been re-architected using the AerOS Meta operating system specifications. We will demonstrate the benefits of this transformation to improve the application deployment automation as well as its resilience to system failures. The AerOS infrastructure element fosters the edge cloud continuum, powered by Kubernetes and Kube edge management capabilities. In Pilot 5, we have constructed appropriate Helm charts to streamline the back-end and IoT system installation in the AerOS infrastructure domains, to automate large-scale integrations and efficient management and communication with all infrastructure components at all times. The service resilience at the edge, leveraging the features provided by Kube Edge, shall also be demonstrated. Let's get started. The Pilot 5 application architecture has been adapted to leverage the AerOS MetaOS domain services and configuration management capabilities. Two AerOS deployment domains are defined. The AerOS application domain, presented in this diagram, is the central entry point for the Pilot implementation where critical applications and AerOS management tools and services are hosted. In the AerOS main domain, IoT gateways are used as edge nodes running Home Assistant, the automation framework for our Pilot, which facilitates smooth communication between IoT gateways and data sources. This setup supports real-time sensor data flow and enhances resilience across the network. Each room in the smart building has an IoT gateway acting as a hub for the sensors, interlinking all infrastructure elements to create a cohesive, fully integrated IoT ecosystem. Utilizing AerOS MetaOS best practices, we developed a Helm chart that allows for quick and efficient deployment of Home Assistant on edge nodes with the correct configurations. This approach enables rapid scaling, allowing multiple Home Assistant instances to be deployed swiftly, making it ideal for large-scale environments. On the left, you can see the Home Assistant interface with all connected sensors actively transmitting data. On the right, our Grafana dashboard visualizes these measurements, offering a clear, comprehensive view of all the sensor data stored in our database. Here we are showcasing our main Home Assistant cluster, the central hub where all our smart sensors are seamlessly integrated. Each sensor sends real-time data from Home Assistant to our backend system via MQTT. An automation is set up for each sensor, sending JSON data with all the sensors' information to MQTT. This data is then transferred to our backend system, InfluxDB, and visualized through Grafana. Here you can see that an action was triggered and a device has turned on. This, in turn, activates the automation we mentioned earlier and sends real-time data, which are then displayed on the Grafana dashboard. Deploying Home Assistant to a new Kube Edge node is straightforward and efficient. In the right window, you can observe the master node managing the Kube Edge cluster. Here you can see the edge node named Virtual Node 1, in which we are going to deploy Home Assistant. First, you'll notice that Home Assistant is not currently running on Virtual Node 1. Next, the node is correctly labeled to allow the pod to be deployed. Now we just need to wait for the pod to be created. Home Assistant is now up and running, ready for sensor integration. Integrating a new sensor is a straightforward process. First, locate and choose the appropriate application from the brand list. Once the app is set up, simply enter the IP address into Home Assistant, and the sensor will be automatically detected and seamlessly integrated into the system. Within moments, the sensor's data is visible in the system, and its real-time measurements can be monitored. To transfer the sensor's data to the backend, we need to set up MQTT and create an automation using a blueprint. This is a one-time integration process for each Home Assistant instance, and from there, you can easily create multiple automations using the same blueprint. After completing the necessary configuration, MQTT is now fully set up and ready for use with Home Assistant. Here you can see a custom home assistant blueprint specifically designed to integrate with all AerOS smart plugs. Each blueprint was carefully crafted to support the unique functions and requirements of each type of AerOS smart device. A dedicated blueprint exists for every different device type, streamlining the integration process and providing a consistent setup for each smart device. Next, we will import the data blueprint. This serves as an automation configurator, containing all the essential information needed to facilitate data gathering effectively. Here we are in the process of creating the automation by utilizing the blueprint we imported. This is done by thoughtfully entering the descriptive information for the sensor, which ensures that all relevant details are captured. This straightforward approach makes it easy to configure the automation, enabling effective data gathering from the sensor. The automation has now been successfully created, and it is configured to periodically send data to MQTT. This data will then be automatically saved in the database. Once the automation is triggered, the corresponding data points will become visible in Grafana, allowing for real-time monitoring and analysis. Data points from the newly added sensor will begin arriving at 30-second intervals, ensuring timely updates and monitoring of the sensor's performance. Now we'll showcase the resiliency of CubeEdge. What happens if the master node goes down? Let's shut down the master node to find out. Despite the master node being offline, you can see that the edge node continues running Home Assistant without interruption. The sensor data is still flowing to the backend and being visualized in Grafana. This demonstrates the robust fault tolerance of CubeEdge, ensuring that even in the event of failure, critical operations continue without disruption. Thank you for watching this demonstration of AerOS Infrastructure's capabilities.